The following is a tutorial for the image processing functions in ScanXm. ScanXm includes some very basic functions for modifying or filtering medical images. These functions are added to help with your annotation or segmentation tasks, to improve the visualization or correct any problems with the images you loaded. On the left you can see the process panel. I've closed all other panels for now. We will start with the crop function at the top. We can use the first button to show a box in the volume. The next button fits the box to the tissue, and if we have a mask loaded, then the next button will fit it to the mask. The button after that will reset the box. We can also adjust the box by dragging the edges to define a region manually. With the two checkboxes below, we can allow the region to go beyond the volume or fix the size of the box by the values defined below. When you are happy with the region, you press the button with the scissors to crop the volume to the box region. Below the cropping, we have the intensity normalization. This adjusts the values to be between the specified range. There are also artificial intelligence image processing tools. I will only show the split CT slices for now, but I will continue to add functions here, so keep checking for updates of ScanXm. So when we look at this CT scan, we can see that it has quite a large slice spacing. As the name says, split CT slices splits each slice into two, so effectively halving the slice spacing. And we can do that as many times as we want. Where there's a clear edge, you can see that this does a better job than just a linear interpolation. You can also see that in the volume rendering, which looks much better now. ScanXm also includes some of the most basic image filters. This includes denoise, which is a median filter, smoothing, which is a Gaussian filter, and a sharp filter. If you are working with medical images, you will likely have already found out that they are not always correctly formatted. To fix this, we can swap the axis or flip the volume in any of the axes. Also, the metadata of the images are not always correct. Therefore, ScanXm will allow you to change these parameters, such as the spacing or origin. Continuing down, we can do a resampling by setting a different voxel spacing and using either linear or nearest neighbor interpolation. In this case, we create a volume with 1 mm isotropic voxels. Before I do this, let me open the info panel. Here you can quickly see the metadata of the image or mesh. When I do the resampling, you can see the spacing changes to 1 mm and the other image parameters change appropriately. This concludes the tutorial for the image processing functions in ScanXm.